9s plus 2 e to the minus 8s. And let me write that, you see, as minus 0.90 times common denominator 14s plus 1. To use the software, I need to write it as a ratio of polynomials e to the minus ds. So multiplying things through, I have denominator is 14s times this, and I'm writing in the order that I'm inputting things in the software. So that's 28s plus 98 s squared plus 56 s cubed is the denominator. Numerator. Minus 3s minus 1, 1 plus 14s minus 0.90. So that's minus 1 times minus 0.90 plus 0.90. And then the first order terms are minus 3 minus 14 makes minus 17 times minus 0.90 is 17 times 0.9. So that's 9 plus 6.3, 15.3. Double check my algebra there just in case.
Is it minus? No, it's plus. Oh,
Minus makes everything. And finally, s squared, I have minus 42 times minus 0.9, so that's 9 plus 3.6, 12.6. E to the minus 8. So that's the first job. I need to make a new body plot. At first, body plot of GU prime for the Ziegler-Nichols method, Felix. And I'm going to do the body plot of GOL for gain in phase margin. Any questions how we got the GOL? Are things making sense?
No, keep going. Keep going.
All right, so let's go to the computer.
Oh.
And we'll do this after you do the body plot. So go back to the software.
Okay, wait. Go easy on the software.
And since I got this mistake, put that back and then click go back. So we need to change the transfer function. So change transfer function. That time is 8. Denominator degree is now 3. So 3 for denominator. Okay, let's look at the 3 coefficients. 4 coefficients. Zeroth order is what? 0. 0, 28, 98, 56. 0. V1 is 0. 28, 98, and 56. So here's what I have. B1 is 0, B2 is 28, B3 98, and B4 96. What's the order of the numerator? 2. And here, going again from smallest coefficient to largest, 0.9, 15.3, 4, 5, 6. Yeah.
I'm not getting 12.6, I'm getting 37.8.
Okay, so let's correct my mistake. So that's 3 times 14. Oh yeah, 42. How did I get it? 12.6. 42 times. When did I do that? Yeah, that's 42 times 0.9. So that's 36 plus 1.8, 37.8, right?
Yeah.
Thank you. Change that to 37.8. The others all correct?
Yeah.
Okay, 37.8. So 0.9, 15.3, 37.8. 0.9, 15.3? 37. Let's double check. So 0.9, 15.3, 37. One is more time. Okay, let's move on. Click to continue. Okay. Again, I can either play with that because I have integral controller. The low frequency asymptote phase lag is minus 90, not 0. But let me do the other method. I'll just give a broad strike on right point 0, 0, 1, and 1, and if I don't like it, I will change it. Oops. Oh, I pressed the wrong thing. Okay.
Oh, what the heck?
I didn't want a specific frequency. So let's try minimum frequency 0.001, maximum frequency 1, and see how we like it. And then I'll go back on the base of that and redo. So let's see the plot. I don't know if that's what it will stay. So you can see that that's pretty close to minus 90, that's doing fine. Minus 180 is up here. It's not too bad. We can live with that. It's not too bad. It's not squeezed up here so we can't draw the line. It's on the part that we can easily draw the line. It's good enough. So I use 0.001, so that's why minus 3. And 1 maximum, that's why you see 0. Minus 2 times 10 to the minus 14 is 0. So I use 0.001 and 1. Okay? So let's bring it into Paint. And I want us to be able to draw. You see all the exam questions. I'm always having you draw the figure. So when you draw the figure and show me the figure, where is log gain margin, and where the figure is the phase margin. And then we can use the table to more accurately calculate. So I'm capturing the screen against the snippet in Macintosh. Okay, so for that, I need to draw the following lines. Minus 180 until I hit phase lag. Go down until you hit and go left.
How do you make the line straight out in this program?
Pressing shift.
Yeah, like
Yeah,
it's
drawing.
more
Holding shift. So are we close from stable?
Yeah.
Yes. This is body plot of GOL. So since it's body plot of GOL absolutely pertains to stability. So we are definitely stable. We are below 0. We have enough gain margin finally. Let's check the other plot. Yeah, close it. Okay, so in terms, and are we above minus 180? Of course we. So if we go now, and I'll put a red color line to indicate, let us use blue. I'll put the blue right here to indicate the boundaries of the gain margin. And type in that color right next to it, log GM, and press opaque. That's log GM, and do the same thing. But then change that to blue. Good. And here we are here. Roughly looking at it, how big is the phase margin? It's about 100, right? Very safe. The gain margin, well, log of GM is 1 over 10 to the minus 0.4. But we have to go to take it back. So let's see what we do. We go now back to the table. We need to find two things here. We need to find the log AR at minus 180. So scroll down until you hit minus 180. It's too far. Okay, I have minus 179.9. That's close enough to minus 1. So log AR is minus 0.34. So from graph and table, log AR at omega C naught was minus 0.34, 334. Yeah, 334. So gain margin is 1 over 10 to the minus 0.34. We'll calculate that. And phase margin is going to be, I need to now look for phase margin. I'm looking at AR, at log AR. I want to find where AR is 1. So finding AR equals 1 means finding log AR equals 0. And you notice that log AR for small frequencies is positive, for big frequencies it becomes negative, so I need to see where it becomes 0. Okay, somewhere here. So I go from 10 to the minus 4 to minus 10 to the minus. That's about the close I have to 0. And what's the phase like that? Minus 80.8 degrees. Right?
I can't tell where you're looking. What?
I'm looking at where log AR changes sign. So you can see here. You can see where the arrow is. Positive, positive, negative, and the closest to 0 is this one. Minus 1.8 times 10 to the minus. And that has phase lag minus 80.79 or minus 80.8. Okay? So the phase margin is minus 8 was 79.
You take the
80.79, 80.8 minus 80.8 minus 180. So that's 99.2 the phase margin, very easily satisfied. How about the gain margin? Questions?
You take the value before it changes signs or after?
The one closest to 0. So, what did I have? I have 10 to the minus 3 positive, 10 to the minus 4 with the 1 coefficient, minus 1 times 10 to the minus 4. So that's pretty much.
The positive or the negative value?
Whichever is closest to 0. You look at, and if you want, you interpolate if you between two values. Okay, so let's go to Excel using this calculator to find out what the gain margin is. So the gain margin is equal to 1 over 10 to the minus 0.334. Oh,
Because GM.
4 more minutes.
okay, 2.16. Okay, so we had a gain margin of 2.1 and a phase margin of 2. So I would have felt comfortable using this. So a lot of concepts today, and I apologize. I have a lot of unintentional mistakes today. But I was glad that you all caught my mistakes, and hopefully your notes are now okay.
Have a good weekend.
Well, I'm seeing most of you at 3:30 for the other class. Not you.
See ya.
Any questions? We still have 2 minutes.
No.
We still have 2 minutes. Any questions? All right. You will say that in all the exams, I like to ask certain types of problems. And one problem I like to ask is modify your controller gain to achieve a given gain margin. So you'll see all the exam problems questions. First, do Ziegler-Nichols, find the gain margin and the phase margin for Ziegler-Nichols, and then without a new plot, without a new body plot, modify the gain margin, modify Casey to have gain margin exactly equal to or exactly equal 1.8, whatever. Give you a specific value. I will do such problems. Maybe I'll have time to do one of them on Monday, do more reviews. But the key to all those problems is factoring GOL with the absolute value of the unknown KC. Same business we did before with JU prime. Factor GOL if you want as a GOL prime that doesn't have KC times absolute value of KC. You get the quantity from what it is without the KC from the tuning you already have. From the body plot you already have, you have that. Okay? And then you just solve for the new gain margin because you know what? The gain margin is equal to 1